Hello everyone, welcome to another Kinetic tutoring episode. Today we're looking at a kinetic energy and work problem, so let's get straight into it. A student slides her 80-kilogram desk across the level floor of her dormitory room a distance 4 meters at constant speed. If the coefficient of kinetic friction between the desk and the floor is 0.4, how much work did she do? Alright, so let's get started by just writing out our work equation. Our basic work equation is simply force times distance, which means how much force she applied on the block and for what distance she applied it for. So we know right off the bat the distance is 4 meters. That's what we were given. So it's simply going to be 4 times the force that she applied. And in order to find the force that was applied to the desk, let's draw a free body diagram. First, let's draw a regular diagram. Here's the box. It's getting pushed this way by the girl here. Alright, and now let's draw the free body diagram where we call this point the desk. We know that we have gravity going this way. Force of gravity is mg. We have the normal force this way, and we have the force that is being applied by the girl. We'll call it F girl. And then we have the frictional force, FF. Now, since the box isn't going up or down in the air, we know that the acceleration in the y direction is 0, meaning that the forces cancel out and are equal. So our n is going to be mg. And let's look at the x. It says here that the speed is constant, meaning that the acceleration is going to be 0. So if the net acceleration of the box is 0, that means the net force of the box is also 0, because our force equation is mass times acceleration, meaning that if our acceleration is 0, our force has to be 0 as well. So that means that F girl is going to be equal to the frictional force. Now let's just find what the force of the girl is. We know that our frictional force is simply mu, which is our friction coefficient, times our normal force. And we know that our normal force is simply mg. And now let's plug in this force mu mg into our work equation. I'm going to erase all of this so we have a clear board. Our work is going to be equal to 4 mu mg. And from here, it's all just going to be plugging in and calculating. We see that we have our mu coefficient. Mu is 0.4. M is 80. And we know that our gravitational constant on Earth is somewhere roughly around 10. Now from here, let's just multiply these out. 10 times 0.4 is 4, so we get 4 times 80, which gives us 16 times 80. 8 times 8 is going to be 64, times 2, 128, times 10, gives us a work value of 1,280 joules. Remember that our work is, the unit for work is always joules. And if we take a look over here, the closest answer we're going to find is B, 1.26 kilojoules, which we know that 1 kilojoule is equal to 1,000 joules. So 1.26 kilojoules will be 1,260 joules. And the reason that this number is slightly lower than the answer we found is because the people who created this problem probably used a value of 9.8 for gravity, causing their value to be a little smaller. But on most exams, on FRQ portions, they will accept a value of 10 being used for gravity. So in this problem, the correct answer is going to be B, 1.26 kilojoules. I hope this helped, and make sure to tune in again later for more physics tutorials.